Hello and welcome to our lesson on pollution. Whenever we're talking about fuels, you need to remember that we're talking about hydrocarbon fuels. And a hydrocarbon fuel, as you should know, contains only hydrogen and carbon. And when we're talking about using fuels, we are burning fuels. And that means we are reacting it with oxygen. So we also have oxygen. And this is combustion. So complete combustion is when there's plenty of oxygen for the fuel to burn in, and it's the posh word for burning, okay, combustion. So what are the products I could make from the burning or the combustion of a hydrocarbon fuel and oxygen? Well, if you remember the rules, the first question we ask ourselves is, can we make water? Yes, we can. We have hydrogen and we have oxygen. The second question we ask ourselves is, can we make carbon dioxide? Yes, we can, because we have carbon and we have oxygen. Do we have anything left? No. So the products of any combustion reaction, and it doesn't matter what fuel it is, because it's a hydrocarbon fuel and it has hydrogen and carbon in it, and because it's combustion, which means we're reacting with oxygen, any combustion reaction will always make carbon dioxide and water. Water is obviously not a pollutant as such, but carbon dioxide is a pollutant. So burning anything, any fuel, will release carbon dioxide gas into the atmosphere. Now, why do we do combustion? Why do we bother? Well, it makes a lot of energy, whether that's heat energy or light energy or turning it into kinetic energy. It makes a lot of energy. This carbon dioxide gas leads to an increase in the greenhouse effect. An increase in the greenhouse effect leads to global warming. They are not the same thing, but they are definitely connected. And you need to have in your head that carbon dioxide is the reason for the greenhouse effect and reason for global warming. Global warming obviously then leads to climate change, and this is what some of these pictures are here. So climate change, you get flooding, you get ice melting, you get droughts where there used to be floods, you get floods where there used to be droughts, and you get extreme weather like hurricanes in the south of England, which never used to happen. So going back to looking at our hydrocarbon fuels contain hydrogen and carbon, but they often also contain a lot of impurities. So they're still hydrocarbons because the fuel itself is still hydrogen and carbon only, but stuck inside that are other impurities such as sulfur and nitrogen. And of course, we're still burning them in oxygen, so we also have oxygen. So what else are we going to make alongside the carbon dioxide and the water? Well, sulfur and oxygen would make sulfur dioxide, and the nitrogen and the oxygen would make nitrous oxides. Now, the reason it's oxides is because it might be NO, it might be NO2, it might even be NO3. So there's a variety of nitrous oxides it can make, and why and wherefore is beyond GCSE, but that's why we call it nitrous oxides, because there's many types. So combustion of a fuel will also make sulfur dioxide and oxides of nitrogen. Now, it depends on how dirty the fuel is. So clean fuels will have less of these impurities, and dirty fuels such as coal will have more of these impurities, and therefore would add more sulfur dioxide and more nitrous oxides to the atmosphere. Both of these chemicals are gases, and so they travel up into the atmosphere and they react with water. So you have another chemical reaction going on here. So here's the sulfur dioxide reacting with water to make H2SO4, which you should know as sulfuric acid. And the nitrous oxides, I've used NO2 here for ease, reacting with water, will make nitric acid. Now, the nitrous oxides only react at high temperatures, which is why the combustion is important. Nitrogen is relatively unreactive on its own. But you put it in a car engine with high temperatures and it is going to react. But the point is, both of these here that are being made are acids, and this is where you get acid rain. Okay, so carbon dioxide does not make acid rain. It's the sulfur dioxide and the nitrous oxides that come from the impurities that cause the acid rain. Okay, so you've got to remember then that it's this sulfur dioxide and nitrous oxides that are linking to acid rain. And you will be asked that question, why is, what sort of pollution? If you just write pollution or if you put air pollution, you're not going to get the mark. What sort of pollution is caused by sulfur dioxide, acid rain? You need to get that right. Now, if you look at some of these pictures, I just want to explain a couple of things here. So first of all, this one here. With the leaves, it looks like this is what the picture here, the cartoon shows here. The rain has fallen on the umbrella and the acid has eaten away at the umbrella. That's simply not the way it happens. The acid is not strong enough. The reason this leaf looks like it's got holes in it, or it has got holes in it, and the reason these trees have been stripped bare is not because the acid rain has fallen on the leaves and kind of dissolved it away. What is happening here is the acid falls on the ground and it gets into the soil and it reacts with the minerals in the soil. And this stops the plants absorbing those minerals that it needs for growth, and therefore the tree can't grow leaves properly, and the leaves that it does grow ends up with these holes. So it's not to do with the rain falling on the leaves or the trees, it's to do with the fact that the acid rain reacts with the nitrates or the minerals in the soil, and the trees can't absorb it, which means they're nutrient deficient basically. Similar here with the fish. These fish have not died because the rain has fallen and suddenly the entire lake is massively acidic and everything's just dying because it's so acidic. The reason these fish have died is malnutrition. They're hungry, and what's happened is it doesn't take much change in pH of the water for the bottom of the food chain to really start to suffer. So the plants and the microscopic plants and the microscopic animals at the bottom of the food chain, which are food for these fish. Now, once they're damaged by a very small pH and they die, there is no food for anything further up the food chain. So things die because they're hungry, because they have no food, rather than because they have been zapped somehow by the acid rain. This picture here is just showing you how acid rain affects particularly limestone. Limestone is calcium carbonate, and it's a chemical reaction that releases carbon dioxide actually back into the atmosphere. But this is particularly limestone, not so much granite, but it does corrode rocks as well. And the reason I've put cars in this picture here is that a lot of these impurities that we're talking about here, the combustion with the impurities in, is going to be car engines like petrol and diesel. They contain quite a lot of impurities, particularly diesel. So far we've talked about complete combustion, where there's plenty of oxygen for everything to burn completely, combust completely and make the carbon dioxide. But what happens if there's not enough oxygen, if it's in a restricted environment where maybe your car's not running properly or the boiler in your house is not working properly and you're not able to get enough oxygen to that fuel? Well, then you get incomplete combustion. So instead of carbon dioxide, which is CO2, you get carbon monoxide, which is CO. Or you don't get the oxygen at all, you end up with solid particulates, so just lumps almost of carbon. Obviously they're very small lumps, but bits of carbon, bits of solid leftovers where the fuel has not been able to combust properly. And there are dangers to both of these things. Okay, so you need to link the pollution, solid particulates, with the consequence, global dimming. So if you look at the picture down here, and even the picture here, you can see the smog. Okay, so smog is a kind of combination of smoke and fog. That's where it's kind of coming from, and this is a consequence of incomplete combustion. So I think this might be LA in the 80s. I know it was definitely a problem in the 80s and the 90s in LA. Lots of incomplete combustion, and there was a smog over the whole city. This, I think, is in China. Massive problems with air pollution in China in the big cities, where they're burning a lot of fossil fuels, and it's not burning properly, and you end up with this smog. And within this smog are solid particles that you're breathing in. And this is why these people are wearing masks, to protect their airways. So what kind of damage can it do? Well, to your airways, just like any sort of air pollution, a bit like smoking, it damages your respiratory system, it damages the airways and the lungs, It's going to lead to things like bronchitis and emphysema, potentially cancer, all that sort of problem. And then of course it can affect the rest of the body as well. The picture up here with the DNA is linking this idea to particularly younger children, people who are still growing. The DNA is still replicating at quite a big rate. And if you're breathing in these solid particulates, a lot of them are carcinogens, which means they're cancer causing. They can lead to cancers in the body. And the younger that you are, and if you're still growing, this is going to affect you more than an adult, because as adults, we've kind of done all our growing, and we're not, even though we are making new cells, we're not making them at the same rate. So what about the dimming part of it? The main problem with the dimming, it makes less light, or less light gets through to the earth. Well, that's a huge problem for plants. And it's a huge problem if you're trying to grow plants for food or to feed cows for food. So global dimming means less photosynthesis in plants, which means less food production, which means the prices are going to go up. Carbon monoxide then is toxic or poisonous to humans and other animals. And the reason for this is carbon monoxide is just a little bit smaller than carbon dioxide. And that means it can get into your red blood cells instead of oxygen, which means when you're breathing in, you're not absorbing oxygen, you're absorbing carbon monoxide. That means your cells are not getting the oxygen it needs. Your cells start to die, and so do you. And the big problem with carbon monoxide is that it's a silent killer. You can't smell it, you can't see it, you can't taste it. And so by the time you realise there's a problem, it's too late. So how do we mitigate the effects of these pollutants then? Well, first of all, carbon monoxide and nitrous oxides, we're going to use a catalyst. So a lot of these come from the incomplete combustion in car engines or lorry engines. And so a catalyst or a catalytic converter is used on the exhaust system to convert carbon monoxide into carbon dioxide. So you can see here, carbon monoxide comes from the engine, it goes through the catalytic converter and it comes out as carbon dioxide. The nitrous oxides go in and they are converted into nitrogen. And what's actually happening is that the nitrogen from the the oxygen from the nitrogen is being given to the carbon monoxide. So this becomes N2 and this becomes CO2. And CO2 is a lot less dangerous than carbon monoxide, and nitrogen is pretty inert. Okay, so pause the video and have a go at this question for me, please. Okay, so it says write down one problem caused by carbon monoxide. You might simply say it's poisonous or it's toxic or it's a killer, something like that. Again, killer, a silent killer, you're probably not going to get the mark because it's not specific enough. How is it killing? It's killing because it's poisonous. What part of the car removes carbon monoxide from the exhaust gases? It is, of course, the catalytic converter. Okay, so pause the video and have a look at this for me, please. Okay, so it says explain how the oxides of nitrogen are formed in an engine. So what they're looking for here is that the nitrogen reacts with the oxygen in the air, and that is done at high temperatures. If you remember, I said nitrogen is relatively inert and it needs a high temperature for it to react with anything. Okay, and then it says most vehicles are fitted with catalytic converters. They reduce the amount of oxides of nitrogen released in the atmosphere. Why is this important? So again, if you said reduce pollution, you're not going to get the mark. We need to talk about specifics. So it's acid rain or lake acidification or corrosion or something like that. But acid rain is the most obvious one there. But you notice there's no pollution there. It doesn't allow it. It's not specific enough. So we mitigate the effects of the sulfur dioxide by capturing it and reacting with it to make it safer. And it looks something like this. So the sulfur dioxide gas comes into this container, and obviously it's a gas, it's going to travel upwards. As it travels upwards, it's going to meet this limestone shower, and this is powdered limestone. Limestone is calcium carbonate, so there's a chemical reaction here, and you make a solid calcium sulfate, which then drops to the bottom. You can filter it off, and it makes other clean gases which can then escape, and it's not as dangerous. Now this calcium sulfate is fantastically useful. We can use it in plastering for houses, so actually it makes a useful product as well.